So we got 30 minus 5, and of course we got 0 over here, right? Plus 30 minus 5, and therefore this is all equal to 25, and I believe that's what we got. I hope that's what we got anyway when we did all this by hand, right? Did the long way around. We got 25. 25. Right. So we had to break this up. We broke this up into three really separate pieces, and this part right here we use the formula. And of course this one right here, um, we just kind of wrote it out longhand there if you want. Okay. Alright, let's look at another one. So this time we're going to look at this one here. We're going to be summing up going from 0 to 3 of I squared minus 1. Wait a minute, we just did that. Never mind. Let's go to the next one here. The summation of k equals 1 to n. So this is a more general case here. We have 1 over n k squared plus 1. So let's work that one out. See if I can make a better summation note sign this time. We have the sum of k equals 1 to n of 1 over n, and then in parentheses times, in parentheses, k squared plus 1. So k, we're starting at 1 here, right, and going to n. But this piece right here, this coefficient, which is not going to be changing at all because we're not going to be plugging anything into this n here. We're just going to be plugging numbers into the k. So what I want to do here is go ahead and just take this out front and just get it out of the way. Get it out of the way. So this was something similar that we did just a little while ago, but I think it was a minus 1, and of course I believe we started at 0 here. But that's okay. Alright, so we're going to write this out as 1 over n, and I'm going to start a bracket here or parentheses. This doesn't matter, we'll start a parentheses. So I'm plugging 1 in, so 1 squared plus 1, and of course I'm going to put this in parentheses, plus, and then we're going to go to 2 squared plus 1, plus, and then I'm going to go dot 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 and then do another plus. In other words, there's a lot of terms in here. Between this term and the next term, there's a whole lot of terms there. And then we have, we're going to n. So we just say n squared plus 1. So this might be a little confusing. So we're not actually getting a number out here, right? I'm just showing what this sequence actually looks like if we were to write it out. All right, let's do one more here. Something that we're going to be more likely that we're going to be working with here shortly. We have the sum of I equals 1 to n. This time we're going to use the function f of xi, and we're going to delta x. So we have f of x1 delta x plus f of x2 delta x plus, and once again dot dot dot, meaning there's a lot of terms and there, plus, and then f of x to the nth term times delta x. Now what you could do is you could factor a delta x completely out of this if you want. You can pull the let's pull a delta, or let's write it like this: f of x1 plus f of x2 plus dot 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 plus f of xn, all in parentheses, times delta x.